Hello everyone, and welcome to today's webinar, Using Ansible to Optimize Your SAS Configuration. My name is Michael Dixon, and I'm the Managing Director here at Celerity, and I'm excited to be hosting this session today. I'm pleased to introduce today's speaker, Cameron Lawson. Cameron is our Services Manager here at Celerity and has presented on many technical aspects of SAS. And today, he's going to share some information around using Ansible to keep your SAS environment in check and optimized, and some approaches that we take here at Celerity with our SAS customers. Before I hand the mic over to Cameron, I have a few housekeeping items that I'd like to cover about this presentation and our webinar platform. Firstly, today's webinar will be available on demand after the live session and will be accessible through the same link you're using now. Next, we'd love to hear from you during today's presentation. If you have a question for our speaker, please feel free to send it through to the Q&A tab at the top of your chat window. We'll be answering questions at the end of the session. If we don't get to your question during today's webinar, we will be sure to follow up afterward. So, without any further ado, I'd like to kick things off by welcoming our Services Manager, Cameron Lawson. Cameron, over to you.
Hi everyone, thanks for joining us today. This is the second webinar and fourth actually, presentation that I've done around Ansible. I think this will probably be the last webinar that we do on Ansible and SAS 9. We may look at extending this in the future to looking more at VIA, just depending on demand and so forth. Today, what we're going to talk about is really about, we're going to build on our previous webinar in particular and look at how we actually optimize the running of Ansible when it actually applies to SAS configuration. In our previous webinars, we covered off pretty much like Ansible 101 and sort of set the scene for where Ansible can actually fit within your SAS config, like your SAS platform administration and configuration management strategy. We looked at Ansible fundamentals, so the structure of how Ansible works and the key concepts within Ansible and the objects and so forth. We looked at how provided some recommended practices on how to structure your Ansible projects. And then we also covered off how Ansible itself is actually configured to enable better performance, more reliable performance, and so forth. And then we also covered off some sort of more higher level topics as they relate to SAS configuration, about the types of tasks that you can run, and some of the gotchas and pitfalls of when you were dealing with SAS. This webinar in particular is going to start sort of showing some strategies and techniques around handling some of those pitfalls. What we'll be doing is I'm going to basically go through some of the theoretical concepts, firstly, just around how what we actually mean by optimization, which is essentially like removing the manual configuration processes, performing changes only when required. There's a concept called idempotence, which is quite important in the concept of configuration management, and then also being like self-correcting when errors occur and so forth. Once we've actually done that, what we're going to do is then actually go through, we're going to actually show you basically an Ansible process that I've actually written with one of our clients. I've taken out, I've adjusted it slightly to basically take out any references to that particular client and so forth, and I've condensed it down into a single file. In the real world, the structure that I'll show you, typically you would actually break these playbooks up into multiple files, so that way you could just call a certain portion of that at any one time. And then following that, it's then some Q&A, and hopefully we'll have a good amount of time to actually look at questions and answer any that you might have. So when we talk about optimization, the real thing that we're basically optimizing here is basically around removing the manual configuration processes in your platform administration and your configuration management strategy, and that's really one of the main points of using Ansible. It's automate all the things, so to speak. So when you think about when you should actually automate and remove this manual handling, look, the key driver from my perspective is, do you perform that task repeatedly? Do you perform it more than once? If you perform it more than once, consider automation. There's no point. Like if you're doing the same thing again and again manually, you leave yourself open to errors. You also, it's mainly around errors. You can also build a playbook for it and make that process self-service. There's, in a previous webinar, we talked about there's actually some front-end tools available as well. You can actually create playbooks, put them into Ansible Tower or AWX, for example, and put the permission strategy in that tool to let users run those playbooks as they need on demand. One of the prime examples of that would be something like if you have a DI, a group of DI developers, and they're using project repositories. Build a playbook to actually create the project repository for them for new projects, and instead of actually having to give them management console and so forth, you can actually just run that Ansible playbook, and it's generally a lot safer, particularly with the project repositories. For a DI developer to create those, you need to give them access to the metadata component of Management Console, and one wrong click in that, you, as a platform administrator, are going to have a really bad day. What's also important when you're actually doing this removing of manual handling is take a step back first, and identify your processes and map them. And within Ansible, where it's really key is your input data, your output data, the process steps that you're actually running, what error handling you need, and the servers that are actually in scope of those processes. This becomes really important from an optimization perspective, is that Ansible, the way that the language of Ansible is constructed, i.e. through YAML files, you run a risk actually of when, if you just keep bashing out YAML files and playbook after playbook, it gets very confusing once your actual footprint with Ansible becomes a lot larger. When it becomes a lot larger, it becomes very confusing in trying to basically manage those playbooks. So first step, take a step back and come up with a strategy. In terms of the other component of this, in terms of removing the manual handling, take out the step of where you actually even have to run the playbook yourself. You can schedule them. Ansible is run through a command line. You can schedule it through cron, Windows Task Scheduler. You can also schedule it through Platform Process Manager. If you've got the OEM license for that through Data Management Server or Grid, use typically have to wrap it in a SAS program and enable X command. You can also run it through the process orchestration server if you've got data management, which lets you actually run batch files and shell scripts. Another important component of optimizing your configuration management strategy is to configure only when it's required. So don't run your configuration management if you don't need to. And in your Ansible playbooks, you devise strategies to either to let the process identify when something has changed, or manually do that yourself. Standard tasks, for the most part, generally all standard tasks will have that concept inbuilt. It will only report back if something has changed. And underneath the covers, it first does a comparison. If you're using raw shell script or Windows batch commands, that's actually not the case though. You have to actually manually handle that concept. Now, unfortunately, with SAS 9 in particular, it's a proprietary application. Most of the interfaces into managing and configuring SAS are through SAS command line tools. So as a result, you've got to actually have a think about how you want to actually perform this type of task. And the example code that I'm going to actually walk through with you actually shows a couple of those strategies that you can actually employ. Other things that you can do within Ansible is you can use the when filter. So this is actually really useful for execute a task when it's basically like a where filter in a SQL query clause. And then also you can use handlers, and the code that I'm actually going to show is actually using both of these concepts. It's using a standard task to actually identify if something actually does need changing. And if it has changed, then we're using when filters and we're using handlers to actually execute the real tasks that are required. The other important component is when you're actually running these processes is to self-correct if errors occur. So out of the box, Ansible will actually perform rollback on most of their tasks if there's an error. And the way it does that is underneath the covers. It actually typically creates basically a working copy of the object that it's actually modifying. And if that's successful, then it replaces it. So that's typically the case, in particular with any kind of file-based operation. It normally does that. If you're having to use shell scripts and batch files, put error handling in them. They're the types of techniques that you try to actually do. So when we talk about strategies for SAS configuration, we're really we're looking at four key topics, really in terms, or four categories, if you will, for Ansible, for SAS 9 administration. Typically, we're dealing with either configuration files, SAS metadata, and that's SAS metadata operations, the file system, and then lastly, service operations. So that is running basically making sure that services are up, services are stopped in the right way, and so forth. From the file system, we're looking at our SAS work area. We're looking at our folder structure to contain our SAS projects and our SAS data and SAS libraries and so forth. On the metadata side, whole range of tasks, which we're all aware of. Metadata security uses project repositories and so forth, ACKs, etc. Configuration files. Most of SAS is a big part of SAS 9 is handled through a myriad of configuration files. And that's right across the product range. Ansible is really well suited to that because it's got really robust file handling procedures built in. And when we're sort of looking at those categories, there's basically some certain modules that are your go-tos, your go-to defaults for handling that type of work. So on configuration files, typically you're looking at either the template module or you're looking at what's called the line and file module. The main differences here is when you're actually thinking about your strategy for configuration management, you look at it in terms of, do you want to have complete control over that configuration, i.e. the zero configuration drift in that file? So that might be something like your app server auto exec file for an application server. You only want content in that file that matches what you expect. The template module is perfect for that. It will do a complete replacement of the file based on data that you're actually managing from Ansible. The line and file module is useful for when you actually want to have just a minimum set of requirements in your configuration. So once again, if we think about the app server auto exec or the SAS v9 file, we might always want to have, like in SAS v9 config, we might always want to have no X command in there. And we want to make sure that if anyone goes in manually and changes that, we can go back and change it. Any other values that are actually in there, we don't really care about. Like delegated users might be able to add and modify other values, but we must always have that no X command. Line and file works well in that it will actually target a specific line of text, either through a regex expression or just an explicit text string. When we're talking about SAS metadata, this is where it actually gets a little bit more hairy, and you're starting to actually really do a lot more manual work in your configuration. There is still a reward at the end by putting it through Ansible, however, but it is more work. And really what we're looking at is the command module, the SSH module, and the raw module. Template module as well to a degree, and that's normally used as a code generation process. So there are some subtle differences in Ansible around each of those three modules that I just talked about: command, SSH, and raw. Command will execute a shell command, on a target host. It's useful for when you don't have a lot of restrictions. Like if you don't have any restrictions on the commands that you can execute, command works perfectly. Where it might fall over, however, is if you've got a sudoers file and you've got modifications in there, restrictions put into your sudoers file, where specific commands might be locked down. And if you've got full paths of those commands, so for example, instead of, you might have lockdown chown, for example, and in your sudoers file, it might be set as /bin/chown. Command may not work because if you're using the Ansible concept of what's called become, where you basically become sudo, it will actually pass in the interpreter first, and if that's not actually part of your sudoers file, it falls over. Alternatively, you can use the SSH command, where you actually manually SSH into a target server, and then you execute a given script, or you use raw. And raw is actually where you would actually define the SSH process yourself. So raw is the lowest level command that you can pretty much run in Ansible. It gives you 100% control over what you can run. However, the trade-off there is that you basically have to manually handle all of the key configuration types of processes and steps there, like idempotence and error handling and so forth yourself. On file systems, the main module, of course, is the file module. That lets you create files and directories. It lets you delete them. It lets you set ownerships. It lets you set permission bits, etc. So if you're configuring like work folders and utility folders, libraries, and so forth, the file module becomes your friend there. Sometimes you might want to actually do lower level permissions, and I've got one client in particular where we make heavy use of ACLs, and that's there's inbuilt ACL modules there which will basically run set facal for you. Again, the template module is a really useful module, and it works across just about everything, and that's where you use it as a code generation tool. On the service side, you can manage your services through the service module, or on Windows, the Win Service module, and that gives you full control over services. On the Linux side, when you're talking about SAS 9, typically we will use just SAS.servers for that, in which case we'd be sort of going more into the command or SSH area. But on Windows, for example, where there isn't really a SAS.server script, the Win Service module becomes really useful there. You can actually you can define your start and stop order and basically do the same process as what SAS.servers is doing. It's also very useful there for actually for actually querying the state of your service, and that becomes useful on Linux as well, actually. When you start, if you're managing like a SAS grid environment, the service module actually becomes quite useful if you're handling eGOSH, for handling some of the, like, actually querying some of the lower level items there. So yeah, that's really as like when you think about strategically, how am I going to actually use Ansible? Probably about 95% of what you'd need is covered in these modules here. All right, so we're going to have a look at now a bit of a walkthrough of an example optimization strategy with SAS metadata, and what we're looking at is looking at folder structure and security of a SAS metadata server. This is a pretty typical admin task. You'll have a given set of folders, a folder structure which might match a company taxonomy or an organizational structure, so forth. If you're using just a single SAS lev to handle multiple development environments, so like a dev folder, a test folder, production folder, this is actually where it becomes this is the type of task we're talking about. On top of that, we're then also looking at the security. So a lot of us will use third-party tools like Metacoder and so forth like that to handle the identity synchronization. One of the things that it doesn't do, however, is actually create and manage acts. So what this task will actually do is it's going to actually maintain a minimum set of folders, a minimum folder structure, I should say. And then 2 is actually for a given set of SAS groups. I'm actually going to create acts for those and then assign those acts to those metadata folders. And this is all automated. So what this actually allows you to do then is to actually constantly run this. And in the client site that I've actually deployed this type of process before, one of them, for example, runs it every 15 minutes. And it's actually tied, they're also using Metacoder, and it's actually tied to the batch process in Metacoder. So when that runs, and if there's actually changes that have applied in there, this then also runs. And that's because their metadata folder structure as well is actually very closely tied to their organizational structure. They haven't actually taken it, they haven't gone down the route of which is normally typically better practice, of where you would actually do by business function. But yeah, in this particular scenario, organizational structure made the most sense. So the first thing we look at is what the requirements are of this. The metadata, the SAS metadata folder structure needs a minimum structural requirement. So 3 top-level folders for development, test, and production. Lower level folders in test and production are promoted. So therefore, there's no manual changes made under test or production. All of that is controlled by automated processes. SAS metadata, for the security requirements there, users can create lower level folders under development. Permissions are controlled through ACTs, however, to follow GEL best practices. And SM management console capabilities have been put in place, though, to prevent general users from using Authorization Manager. So therefore, we don't need to worry about checking for rogue acts, where if someone goes in and creates an act to do a particular task and it's outside of our configuration management strategy. And therefore, we're not too worried about that. So earlier, as I mentioned, the first step that we should do is basically come up with a bit of a game plan on how we're actually going to implement this. Think about it in the wider context of your configuration management as well. Are there components in this process that might be shared with other processes, in particular data? So therefore, we map this. We do a process where we actually map out what we're going to do. So we look at the input data. Now, the input data in this scenario is manually maintained in a file. There's no output data as such, so there's no actual output data that goes onto other processes per se. And what do we want to do when errors occur? In this case, we're just going to report them in the Ansible log. How often do we want to run this? We're going to do this every 15 minutes. And it's going to run on the metadata server and the Ansible controller. So when we think about this process, there's some key input data that we need. We need a list of folders. We're going to need SAS credentials. We're going to need the SAS platform object framework paths. All of these tasks, in order to automate, we're going to use the command line tools within the platform object framework folder of your SAS install. From a security standpoint, we need a template in place for our acts and for the groups and the permissions for those groups. We need a mapping of folders to acts. We'll need SAS credentials, and we also need the paths of the platform object framework tools. Excuse me for 1 moment. In our intermediate stages, so this is actually where we're processing stuff, we're going to need a list of folders, list of acts, folders to add, folders to delete. Once again, we're going to need that folder and act mapping, and we're also going to need to know what acts to create and what acts to update. When we're looking at our output data, there's actually no output data requirements in this. So typically what I will do as well is I'll actually list out all the variables that I actually want to use. And that's a good first step because, as I said before, once you actually start building lots and lots of playbooks, you do actually, if you're not careful, you can actually end up getting yourself into a really big mess with duplicate variables and things like that, and just slight variations on names. It becomes really, really confusing. So it's a good idea to maintain just a list of variables of what you're actually wanting to actually create and how you want to structure those, whether or not they're actually just simple key value pairs, or whether or not you want to use lists and dictionaries and so forth. So our strategy here for how we're actually going to automate SAS metadata administration here. It's the platform object framework. It's pretty much that's pretty much what you need to use. There are other tools within that folder. So the key ones that we're using here is going to be make folders, .shell. I think that's at the top level of the platform object framework folder. And then under the tools folder, there's SAS list objects. So that's going to let us list out metadata objects, SAS make act, and then SAS set metadata access. Fairly self-explanatory, those two. The set metadata access lets you assign acts to folders. So because we're running actually just raw command lines, command line tools, we actually need to work out how we're going to actually handle this concept of idempotence, i.e. check to see whether or not your configuration has actually changed and only execute if it has changed. So the way that we do that is that we list objects, compare to an expected list of values, and then run against the items which don't match that expected. So kind of think about it in terms of like data management, kind of like an ETL operation in some respects, or like a Delta process. That's essentially what we're going to set up here. So the strategies that we can actually employ for that is that we're actually using variables and looping concepts. So we create list variables of metadata objects. We loop over those and compare them against another list of expected values, and then using handlers. So just to sort of refresh here, I went over handlers in our previous webinar, but basically handlers are like a trigger in that you can execute a task, and if that task is reporting that it's actually changed, you can then tell it to actually run tasks within a handlers section of your playbook. If there is no change, then those tasks do not run. And this is actually probably one of the more useful ways that you can actually do this within command line tools. As of Ansible 2.2, you can actually configure handlers to actually run multiple tasks. And the way that I've structured the playbook that I'll show you, it's actually pretty much all of the main processing is actually within a handler section. There's only just one task that really runs initially, and that's actually identifying whether or not my data, my source input data has actually changed. So just bear with me. I'll just jump over to so here we have a playbook that we're going to go through. In a real world scenario, my vars section here, I would actually break this up into multiple variable files, and I would load them either within the group vars folder or your host vars folder in Ansible. They will load automatically depending on, like in group vars, for example, I could have a file just called metadata_server.yaml. And any metadata server specific variables, I can actually put into that file, and it will just load automatically if my hosts is actually there. Like if that's the hosts that I'm using, or if I'm using all, like hosts all, it will just load those variables for me. It's good in the sense that it basically keeps, it sort of helps you follow dry principles, and makes it a lot more maintainable. Same with the tasks that we'll go through. Quite more typically, I would actually break up these tasks by the functions. So the checking of my input data would be one playbook. The metadata folder creation and management part is another playbook, and the SAS Acts and general metadata security is another playbook. I'll then have a fourth playbook that would then actually call those as one single process. That then gives me a lot of flexibility to, if I only want to run the metadata folder component, I can just run that. If I just want to run the Acts component separately, I might have a different schedule to that, I can just run that. So these are some of the strategies that I was talking about earlier that you actually sit back and have a think about before you actually start putting down a single line of YAML writing of a playbook. So the key variables that we need is, of course, we need some SAS user credentials. In a real world scenario as well, these would be definitely in a separate file, and we would also encrypt them using Ansible Vault. Just to note, that's not a real password for anyone who likes to copy things out. I've also actually set up here using templating variables some constants for when I'm running the SAS Platform Object Framework. So I have a SAS home variable, which is actually getting loaded within the inventory. So here I'm setting it to basically the root path of the Platform Object Framework. And then for each of those tools, the command line parameters are basically like there's a set of common command line parameters. So I don't actually have to type them all the same, or put them into my playbook every time. I've just assigned them to that variable, POF creds. Now, what this playbook's doing, it's actually going to create 3 top-level folders at the root of the metadata server. So /development, /test, /production. Development has a different security strategy to test for production. So what I've done here is I've actually created 2 variables, one called dev_env, which is just my development environment, and then controlled envs, which is basically, these have a common security profile. As a helper, I just created this other envs variable where I just concatenate the 2 lists. So once again, another strategy here for helping to keep your playbooks, limiting duplication in your playbooks, and so forth. These aren't really, I'm not really going to go too much over these. These are actually more for the file system. The same data that I'm using here, I actually use elsewhere in the site that I've taken this from to actually manage file system permissions as well. And here I've started to actually map out some defaults for my Acts. And the way that I'm structuring these Acts is that I have an overriding read and a deny Act. And then I have lower level Acts which enable read-write access, basically write metadata or write member metadata access based on different teams. So all of these are all just straight key value assignments. This here, which is basically the listing of my teams. And this is where you would actually manually maintain. So if you've got additional teams, you would put them into this variable here. You might not actually want to manually maintain that. If you want to actually have that controlled through an automated process, you can as well. So in one site, I actually use SAS groups that are AD groups that are actually extracted from through the AD sync process. And I'm creating and I can create folders based on that. And this structure here is actually created from script. But it's actually all completely hands-off then. But the main content that I'm actually putting in here is a name for the the area. The metadata, like the actual metadata folder name, and the SAS metadata security group that I actually am using. And these will actually go into the ACS definition. I then have basically a pattern for my read and deny. And this is really just, this is a pretty stock standard where we're going to deny in public, give read to SAS users, and give administrators everything. Now, the playbook structure. As I said earlier, what we want to try and do here is not actually execute the platform object framework tools if we don't have to. And that becomes quite hard, particularly with some of the platform object framework tools that there's no, like most of them don't have any kind of inbuilt error checking or handling of that concept. Some will just fail spectacularly and will just throw back errors to you. The problem there is then that you'll actually, and Ansible will then report that your playbook is in error, which as an administrator is a hassle because it's not doing anything, which is what you want it to do, but it's telling you that there's something wrong. And if you've got monitors and things like that set up on your playbooks, then their alarms and things like that will just keep going off, and you're just going to be just chasing your tail. Looking at faults, looking at those. So what we're doing here is we've got in our tasks section, one task only, and we're actually using a standard Ansible task here, which is a template task. And what we're doing is we're taking this data here and we're combining it with all of this other data to create some new data structures, which will actually get used by the rest of the process. So we're taking in this file here, which is a template, and it's creating a YAML file, which is then used by Ansible in the following steps. So I'm just going to step back here and just run through some of the concepts that I'm actually doing here. The first one, something which I haven't covered before, is there's the ability in Ansible, if you want to actually just run a task on the Ansible controller that you're running it, that might be your laptop, it might be the metadata server, wherever. If you've got multiple servers in your host list, so if you've got hosts all, if you don't have this, it's going to execute on every single server that's actually in your list. So I just want to execute this once because it's actually just being used by Ansible itself. I can use the delegate too. And here I'm just actually delegating it to localhost. So that's the Ansible controller. I have a templates folder in my project structure. And then under my inventory folder, my group bars, I've got a company servers grouping. And I'm writing it to here. Now, this I'll come back to. And I've also, as a good practice, I've also put in tags. And in this scenario, there's just two tags. It's either prepare or execute. So when I'm actually running and debugging the Ansible playbook, I can actually limit the tasks by those tags. And we just use the -L. The -L switch in the command line. So it'd be like -L prepare, and it will only run the tasks that have that tag. So if I'll jump back now to the template, what we're doing is we're creating one variable called folders, another variable called SAS metadata ACS, and then another variable called folder assignments. The templating language, as mentioned, is really powerful. It supports functions, it supports looping, it supports conditional statements, and so forth. Where filters, you name it. So what we're doing here is we're looping over the functional areas. So for each value in this list, and then for each environment, so within dev, test, production, once I find it. Yep. So for each functional area and environment, I'm going to create this list, this dictionary structure. I'm going to set a path attribute, an owner attribute, a group attribute. Owner permissions, and these are more used from the file system in file system management. Then for the SAS metadata acts, we're first of all going to create those global, those more generic acts, and then for each team in that functional area, or each area in that functional area's variable, we're then going to also create an act definition here that's used. And so here we're basically putting in the name, the action that we want to do. So this is actually a platform object framework action. So create, delete. I think it's create, delete, and update. Is global. We don't need to worry too much about that. And then the pattern. So here I'm basically I'm using the templating concept here to basically, for the given SAS group, these are the permissions that I'm actually applying. So in this case, write member metadata and write, and check in metadata. Then lastly, what we want to do is actually take that list of folders and that list of SAS metadata acts, and then create a mapping of those two. And that's what this last step does. So how that actually ends up is it actually produces a file like this. Just another good practice is at the top here, you'll notice that I've got this special variable called Ansible managed. The value of that is set in your ansible.config file. And it's a good practice to put those in any file that you're actually creating with Ansible. Just to let people know that, hey, if you're going to change this, it's not going to make much difference, because next time Ansible runs, it's just going to wipe it away and redo it. So now that we've actually got that folder structure in place, I'll jump back now to our playbook. And the first thing we're doing is we're running the template task. Now, what Ansible will do here is, if there is actually no change in this data, it's just going to say that nothing's changed. Like it gives us that idempotence concept. So nothing has changed. And I've put into this task this tag here called notify. And what notify will do is I've given it an alias called run process. If the value has changed underneath within Ansible facts, this task it has a variable called is changed, or changed when. And if changed when is set to true, which Ansible will do if Ansible detects a change in the data, it's going to execute any task in my handlers with this listen attribute here. So you'll notice here I've got run process. Now, what I've actually done here to basically let this happen is I've attached run process to everything. So every task here is going to execute in order if the data has changed. in this section. So when we're actually looking at how we actually handle and identify changes, there's a lower level here as well. Like, we don't want to actually just go and run make folders across everything, because make folders, for example, will throw an error if that folder already exists, and it will then report back to Ansible to say, hey, the playbook's in error. So what we're doing, first of all, is we're going to list all of the folders using SAS list objects. And we actually load that into an intermediate variable called test data. Again, I don't need to run this on every host, so I'm just delegating it to local host. And I'm then actually going to take that test data, that's the data in there, which is a listing of metadata objects, and I'm just going to clean that up and basically give me a unique list of folder paths that I need. A unique listing of the folders that are actually already exist in metadata, sorry. And then from there, I'm going to create a list of the folders that actually exist, a list of folders to create, and then a list of folders to delete. You'll notice here in this playbook, there's some funky stuff that I'm doing here, where I'm doing a lot of piping and using some of the inbuilt functions. So this is actually this is a good strategy for when your playbook tasks sometimes need a certain structure, and the data that you actually have may not be in that right structure. You get quite a bit of flexibility in being able to actually massage that data into a different structure for what you need. So here, like this, in here, for example, I've got a list of dictionaries as my data. I actually just want a straight list, so I can use map, and I'm just taking the folder attribute, turning it into a list, and then ensuring that list is actually unique. So once I've actually got all of those, like now I've got three lists. I've got what's existing, what I need to create, and what I can flag to actually delete. I can now go and create that tree. Now, the reason I've actually got that existing list is it's important here that I may actually have this playbook, and we may need to actually completely refresh the environment for some reason, like you've done you've moved servers or something like that, and you want to actually just go ahead and create this all again from scratch. We don't want to actually have to go and specially do anything different from our normal process here. So this is actually going to just run, like, use the data in this here. And you'll notice that for each of these, it's actually based on this. And it's actually that value there is actually changes based on whether it's based on the delta. So if I want to create these, then what I'm doing is I then run make folder.shell, and I pass in the make full path just to make sure. So that way, if I've got if my folder structure is development data services or development DevOps, it's actually going to create that full structure for me, and I don't have to worry about the ordering of folder creation. I haven't included it here. There's a few little trade secrets in this one. Is to basically then go and delete. I then actually execute deletion of folders. So this is actually where if someone goes and creates a folder and we don't know about it, we want to delete that. And that's what you put in here. Then lastly, we then actually go on and then create our acts, and it's the same process. Structurally, it's essentially the same process. A list of the acts that are actually already there. Massage that data into a structure that we need. and we give ourselves basically a list of acts that we actually want to go and create, and then we run make act. With this particular command line tool, I don't need to go and check for changes, for updates. This will actually just go and set the acts to the expected structure every time. So I don't need to worry about knowing what's updated, what's actually and versus what's new. Once we've actually made those, we can then set the acts on the folders for that list of folders that we've just created. So that's the overview of how we would actually optimize Ansible to actually run what's normally a fairly repetitive and quite menial, well, not menial, but I find personally annoying task. Creating metadata folders annoys the hell out of me doing it through Management Console, mainly because of how many mouse clicks is actually involved. So what we've now got here is a repeatable process that will only execute when it needs to, and will actually report correctly when something has actually changed and versus when something has actually not been changed. So just wrapping up now, the key concepts here that I'd like you to sort of take away here is consider Ansible when you're configuring, consider Ansible when configuration tasks are repeatable. Secondly, plan your approach. Think about how you will actually need to execute these given tasks in a wider context of your platform management and your configuration management strategy. Schedule your playbooks. It's a lot easier than having to sit there and type out the Ansible playbook command every single time you want to run something. And then use standard tasks if possible. If they're not available, limit what you need to execute by checking for changes first. And so basically just finishing up now. That went a little bit longer. I tend to wrap it on a little bit. We've just got a few more minutes for Q&A. I don't see any Q&As that have been written out. So either A, I've explained this really well, or I've confused everyone. So yeah, are there any questions from anybody regarding this type of process? Okay, well, thanks everyone. And I'll hand back to Michael now, who'll do some wrap up. And yeah, look, thanks everyone for attending. I've really enjoyed giving these presentations on Ansible. It's a topic that's sort of not been it's a bit of a side topic to SAS administration, but still a very important one. And it's something that's quite close to my heart from a professional standpoint, is seeing how SAS and getting SAS to actually integrate with some of these really great tools that are used out there in the rest of the administration world.
Okay, thank you very much, Cameron, for that presentation, and thank you everyone for joining us today. There are no Q&As, so yeah, thank you all for joining. And if you have any questions, please feel free to either email myself or Cameron. Our email contacts should be on the webinar website here or on our website at celeritysas.com. Again, thank you all for joining, and hopefully we'll see you next time for our next webinar.